Welcome to our Precalculus class. The topic for today is Fundamental Theorem of Algebra. I'm going to show you this topic working with this problem. Use the Fundamental Theorem of Algebra to find the number of complex roots of the polynomials, including any repeat roots. Okay, our problem is 6x to the 6th power plus 16x to the 3rd power plus 19x to the 2nd power plus 2x plus 60. Okay, before let me remember you this concept. A number C, in this case, C is a root of polynomial. Px, okay? If P C is equals 0. All right, the fundamental theorem of algebra is if Px is a polynomial of degree and look at this, is very important, n greater or equals than 1 with complex coefficient okay, the Px, the P of x has at least one complex root. That's very important. Remember this concept. Okay, let's try to solve our problem here. Doing the process. Okay, in this case, the first step, we have to find the degree. First find the degree. Find the degree of the polynomial. Of polynomial, okay, of the polynomial. All right, so the degree in this case is look at this, we need to see what is the maximum exponent on the polynomial. The maximum, this is the term, almost the term has x, so this is a first exponent fixed. This is second exponent to the 3rd power to the 6th power, so it's 6. So the degree is 6. So now since it is coefficients are reals, and all real numbers are also complex. Also a complex number you can apply the corollary to the fundamental theorem of algebra. All right, so now our conclusion. So including any repeat root, six, we're gonna write again 6x to the 6th power plus 16x to the 3rd power plus 19x to the 2nd power plus 2x plus 16, okay, has six complex roots. All right, this is our answer. So let's let me show you another problem, same to this one, just with different terms. Let's write another problem. It's very simple. It's just really explaining to you the concept. So the next is the same terminus. Use the fundamental theorem of algebra to find the number of complex roots of the polynomial, including the repeats roots. Okay, now our problem is x to the 5th power minus 10, x to the 4th power minus 13x to the 3rd power plus 18 x to the 2nd power plus 13x, this is right here 10, 13x plus 14. All right, this is our polynomial. So first we have to find the degree. First, that's the first step. First, find the degree of the polynomial. All right. So the degree, the polynomial, in this case, look at this. This is our first, second, third, fourth, and fifth. So the degree is 5. This is very important. Degree is 5. So now just write the concept, since it is a coefficient areas and you can and all real numbers are also complex. So explaining the concept, numbers, you can apply the corollary, the corollary or the fundamental theorem, okay? Of algebra. All right, so our conclusion. So including any repeat roots, okay, our problem here, x to the 5th power minus 10 to the x to the 4th power minus 10 to the x to the third power plus 18 x to the second power plus 13x plus 14. So has, in this case, is plus 14. Here also has how many complex roots? Has, since you see the five complex roots. See? So a solution for this kind of problem depends on the degree of the polynomial. When you see merely the degree, that's exactly the complex roots that you can find it in the problem, right? Got it? So